Hello class, in this presentation we are going to learn how to conduct a simple regression. My name is Patricia Barnett. On our agenda, we will go over the process. We will determine the dependent and independent variables that we will be using within this regression analysis. We're going to analyze the results, in which we'll find no significant result in one test, and we will find significant results in two of the tests. We'll go over our main takeaways. I will show you the reference I used in the preparation of this presentation, and of course we'll close with any questions. An overview of the process. Step 1, as always, we're going to open PSPP and import the data. Step 2, as usual, we're going to state the hypothesis, state the rejection rule, and new for this type of analysis, we're going to go over a confirmation rule. Our null for each of this test is that the slope of the regression is 0, or beta equals 0, which would indicate that there are no significant regressors. Our alternative, the slope of the regression is non-zero, or beta is not equal to 0, which would indicate that there is at least one significant regressor. Our rejection rule, as usual, we reject the null when the p-value is less than alpha, where alpha equals 0.05. And our confirmation rule, 0 is not within the 95% confidence interval, which we'll see when we go over our results. So step 3 is interpreting results. That's the equation we'll be using, where y is the dependent variable, beta is the APA symbol for beta, and x is the independent variable. So the question that we're asking in each of these analyses is beta significantly different than 0? If yes, the regression is significant, and if not, then there are no significant regressors. So within our regression analysis, what are the dependent and independent variables? We're going to be conducting regression analyses between 3 pairs of these variables. And per the instructions, we should find 2 significant results. So our first test, we're going to ask the question, can we predict an individual's debt by knowing their income? In this test, the dependent variable is debt, independent is income. In our second regression test, our question will be, can we predict an individual's savings by knowing their income, in which the dependent variable is savings and the independent variable is income. And in our final test, can we predict an individual's portfolio value by knowing their savings, with the dependent variable being stocks and the independent variable being savings. So in our first hypothesis test, as stated, can we predict an individual's debt by knowing their income? So we're going to conduct a regression and state the following regression was conducted. Here's a null hypothesis. The regression coefficient, beta, is 0. Our alternative, the regression coefficient, or beta, is non-zero. And a simple linear regression was conducted to determine whether observed debt could be predicted from income. Here's the output, in which we found no significant regression. And how we know that is that beta equals 0, the r-squared value equals 0, and the p-value equals 0.535. So from that we see that there is no regression coefficient. It's equal to 0. So we can accept our null hypothesis. And further, 0 is within the 95% confidence interval, which we see on the right. It is negative 0.01 and 0.01, so 0 is within that. And that indicates that there is not likely to be a significant regression and no significant result found. So for our second test, can we predict an individual's savings by knowing their income? So again, the following regression was conducted. Our same null hypothesis that the regression coefficient is 0. Our alternative, will be that the regression coefficient is non-zero. And here's our result. A simple linear regression was conducted to determine whether observed savings could be predicted from income. A statistically significant regression emerged in which beta equaled 0.91, the r-squared equaled 0.82, and the p-value equaled 0. Thus, the test rejected the null hypothesis and predicted savings. And here's a breakdown of the formula that we saw earlier. So savings, the dependent variable equals the beta, which is 0.91 times income plus a constant. So savings is predicted to increase as income increases, which makes sense. And further, the 95% confidence interval of 0.09 to 0.11 does not contain 0, hence it lends to support the prediction, and we found a significant result. In our third test, can we predict an individual's portfolio value, or stocks, by knowing their savings? So once again, we're conducting a regression analysis in which the null states the regression coefficient beta is 0. Our alternative, again, the regression coefficient beta is non-zero. And here's our results. A simple linear regression was conducted to determine whether observed stocks could be predicted from savings. And again, we see a statistically significant regression emerged in which beta equals 0.28, the r-squared value equals 0.07, and p equals 0. Thus, the test rejected the null hypothesis and predicted stocks. And we have our formula there again, in which y is stocks, the dependent variable equals the beta 0.28 times savings, which is the independent variable plus the constant. So stocks is predicted to increase as savings increases, and we know this because the beta is positive. So further, the 95% confidence interval, which we see on the right, 0.07 and 0.25, does not contain 0, hence this lends to support the prediction. And once again, a significant result was found. So our main takeaways. The null hypothesis, as always, of a regression analysis can be rejected if the p-value is less than alpha, which is 0.05. If 0 is within the 95% confidence interval, it is likely that there is not a significant regression. And in APA formatted write-up, there's our equation, where y indicates the dependent variable, beta indicates the slope of the regression, x indicates the independent variable, and c indicates a constant. So the question for each of these is, can we use the independent variable to predict or estimate the dependent variable? And here's the reference that I used. And finally, if you have any questions, please enter them in the comments. And as always, thank you for watching.